Hello everyone, today we're going to be talking about quadratic equations. So this list of equations here, they're all an example of quadratic equations written in different forms. So they're all examples of quadratics. This is a quadratic and all of these are also quadratics, but they can be used to find different things. For example, this quadratic here, that's an example of a quadratic and its turning point form. Okay, now this is general form of a quadratic, this one here, and this one is sometimes called the x-intercept form. And we'll go through what each of these look like on a graph. Okay, so let's start off with graphing this one. It's sort of the simplest quadratic. So we can see that if we graph y equals x squared, we get this shape here. Now, this shape is called a parabola. Okay, so this sort of looks like a V kind of shape at the moment. That's because the A value is positive, and it gives us that sort of a smiley face. But if we make that negative, you can see it flips over. So now I've got y equals negative x squared, and it still has that parabolic shape. So that curve is still called a parabola, but it's just flipped around across the x-axis. Now let's see what happens when we graph a different form of a quadratic. Now we've got the general form of a quadratic here, y equals x squared plus bx plus c. So right now, b and c is equal to 1, but let's just see what happens if we change this b value. So if we move the slider, you can see it moves that quadratic. Now if we move the c, just go, the c value shifts its vertical position. See that? So if we have a c value of 10, you can see its y-intercept is also 10. So c represents the value of the y-intercept when we're looking at the quadratics in the general form. Okay, now let's have a look at the turning point form. So this is a quadratic and its turning point form. So we have y equals a and x minus h squared plus k. Now the interesting thing about this is this point here. So the point where it is kind of symmetrical. So if we imagine that we drew a line through the middle of this graph here. Now if we drew that line vertically straight through 1, 1, then it would be symmetrical about that point. And that is why it's referred to as a turning point. It's also the point where the graph stops sort of going down and starts turning upwards. So that's the turning point, that point 1, 1. Also called the minima or maxima. Now if we have a look at the values for h and k for this example, h is equal to 1 and k is equal to 1. And we have a turning point of 1, 1. So the values of h and k tell us where the turning point is when it's in turning point form. But we have to remember that h is negative in the equation, so we just flip the sign around. So if it was positive h, then the turning point would be at negative h. So for this one it says x minus h, so instead of negative 1, it's positive 1 because we flip the sign around. Turning point is at 1, 1. That's interesting. That's the interesting thing about this form here. Now let's have a look at the final form of a quadratic. Let's have a look at this graph here. So we've got the graph of x minus 2 and x minus 3. Now, this is called the x-intercept form for quadratic because it tells us the x-intercepts. So x minus 2 and x minus 3. The x-intercepts for this quadratic is that x is equal to 2 and x is equal to 3. So x equals 3, x equals 2. They're the values where this quadratic crosses the x-axis. All right. Now, this a value for all of these, a is the dilation factor. So it changes the kind of the width of the quadratic. So it makes it wider, and it can actually make it negative as well, like we saw with the first example. If a is negative, it's flipped across the x-axis. So that's what happens when we change the value of a. All right, so hopefully that makes a bit of sense. A bit of a quadratic, bit of an introduction to different quadratic equations.